Hi, my name is Nathan. I am a cloud architect at Techolution, and I'm talking today about GitOps. What is it? Why do we want it? For context, this is a short explainer video for people who already work with code in some way or another and have maybe heard of GitOps but aren't sure if this is something they want to implement. If you're looking for something more detailed with code to follow along and so on, I've included a couple links at the end of this video and in the description below on some more technical explainers by some of the best people on the internet to follow for this sort of thing. So we'll start off with what is GitOps. Kelsey Hightower, who works at Google, describes it as versioned CI/CD on top of declarative infrastructure, which is accurate but extremely dense. So we'll unpack this as we go. Put a little more plainly, what we're doing here is creating a division of labor between humans and machines. To borrow a line from Victor Farsick, humans are creative but unreliable, whereas machines are reliable but unimaginative. So we want to leave the creative work of defining the desired state to humans and the repetitive work of ensuring that the actual state converges on the desired state to machines. To achieve this, we can follow four simple principles. One, declarative system definitions for everything. So infrastructure as code, configuration as code, operations as code. Everything about the desired shape and function of your entire system can and should be defined as code rather than implemented at the command line. Two, the canonical desired system state lives in Git. So you have a single source of truth that leverages the existing authentication and version control powers of Git. Three, system changes are applied automatically. So a Git commit marks the boundary between human-controlled and automated function. CI/CD tools are responsible for the remaining lifecycle of your code, and this allows you to separate what you do and how you do it. Four, software agents manage state drift. So once the desired state is defined, software agents monitor that state for drift and can act on their own to heal the system back to its desired state. All right, so why do we care? What are the benefits of GitOps? There are many, but a good starting list looks like this. Increased productivity. Continuous deployment automation with integrated feedback loops speeds up mean time to deployment. Enhanced developer experience. People push code, not containers. Allows developers to manage updates and features into Kubernetes clusters using familiar tools without really needing to know much about how Kubernetes works or how to use the specialized tools like kubectl to administer it. Improved stability. Git commit history becomes an audit log of all cluster changes because everything is routed through Git, and this log lives outside of the cluster. So even if the cluster goes down, you can still have a clear commit history of everything that's happened. This allows you to meet things like SOC 2 compliance and ensure overall system stability. It gives you higher reliability. As your entire system is described in Git, you have a single source of truth from which to recover, reducing mean time to recovery from hours to minutes. It improves consistency and standardization because it provides a unified model for managing changes to infrastructure, applications, and operations across your entire system, and enables consistent end-to-end workflows that are all fully reproducible through Git. And lastly, it provides stronger security guarantees by leveraging Git's existing security features backed by strong cryptography used to track and manage changes, as well as the ability to sign changes, attribute authorship, and so on. So implementing GitOps, what does this actually look like? By relying on existing Git infrastructure and methods, we have two primary ways of interacting with GitOps as a pipeline, push and pull. Most CI/CD tools available today use a push-based model. The push model waits for someone to commit code to a Git repo, and then automation takes over from there. This means changes to your cluster are coming from outside the system, in this case triggered by your CI/CD tools. This changes the threat model for system security somewhat, as giving these tools the power to alter your system infrastructure at a deep level. It comes with its own risks, but that power has to live somewhere. And these tools can be made quite secure. Some security considerations to keep in mind in this case. The software agents that manage these deployments on your behalf should have permissions constrained to no more than is required for them to operate, and should probably require human intervention at some point before deploying to production. The alternative to empowering CI/CD tools to manage your cluster via push pipelines is to empower a software agent that lives directly in your cluster that pulls from Git repos that it is set to monitor continuously. In the pull approach, all changes are applied from inside the cluster. The software agent, labeled on this slide as the operator, lives inside the cluster and scans the associated Git repositories and container registries for changes. When it detects any drift between the desired state and the current state will be updated from inside. This process is generally very secure due to the fact that no external client need have credentials to administer administration access within the cluster. That said, your operator will require secrets and service accounts to do its job, and both are potential security hazards if not configured properly. Some benefits to the pull approach. Docker registries can be scanned for new versions automatically, and if a new image is pushed, then the application deployments that build off of that can be sent out automatically. Pull-based tools can be distributed in different namespaces across different repos, and this can give you a multi-tenant model without a great deal of setup. So team A can use namespace A, team B can use namespace B, and an infrastructure team can access globally. The tools for managing this are generally very lightweight and are unlikely to incur a great deal of additional processor time or other sort of resource costs. And finally, if you combine these with a tool like Sealed Secrets by Bitnami, then your system secrets can be placed in an encrypted form inside your main Git repository and only extracted and decrypted from inside the cluster. This allows you to keep 100% of your system defined and securely contained in a single repository without potentially exposing credentials to the outside world. So what comes next? Well, if this method sounds like something that you were interested in adopting at your company, we are here to help. You can contact us at the link below. And if you'd like to do a deeper dive into the tools and processes that support GitOps, I've included some of my favorite tutorial videos on these subjects in the notes below. Thank you, and have a nice day.